In the sixth video in the Foundations of Computational Economics course, we will look at two practical examples to apply our knowledge of the Python essentials in a couple of tasks. So exercise number 1 is asking to code up a function to convert a double index ij into a two-dimensional array into a single index k which swipes the array by column. We also need to code up the inverse of this function. This is actually quite typical problem, probably more of a lower level language applications, but still it's an interesting task. So let me convert to the normal notebook view for you to see it easier. And let's insert a cell here and just move the second task away so it doesn't disturb us. Okay, so let's just start writing a function. Def, I'm going to call it k, because this is going to be a function that converts I and j into a single index k. Converts double index I and j into single k by column. Now, we probably need to know the dimensions of the array. As it turns out, we don't need to know both. It's enough to know the number of rows. Let me just put it. Third input m is the number of rows in the array. Let me just draw the situation here. I'll need a new drawing. And so what do we have? We have an array. It's going to be indexed with I and j. I on the vertical axis and j there. The I goes from 1 to m, and j goes from 1 to n. And now we want to construct an index k, which is equal 1 over here, 2, 3, all the way to m, and then m plus 1, m plus 2, and so forth. And in the last cell, it's of course going to be m times n. So, yeah, how do we calculate that? To calculate k, let's think about it. So, k will basically surpass so many columns that there are j's. So, we'll have m times the number of columns. Imagine that k is somewhere over here. Say this we're trying to make an ij for the k, which is right there. That means that two columns have sort of passed in the enumeration of the k, and so many rows as well. Well, how many columns? If k corresponds to the index j, that means that j minus 1 column has passed. And so we can safely put j minus 1 here. But then we also have to add all of these rows that are part of this column. And the row is, of course, measured by or indexed by I. And that seems to be about it. So we can just return this. I can type today. Return this. What about the inverse? So let's call the inverse ik. It will take k as an input argument, m as well. I can say inverse of k of ijm. And let's think about how to construct the inverse. Looking at the picture again, so if we know k, we need to see how many columns could fit into that index. And of course, the number of columns is going to be given by k divided by m in some sort, right? But k divided by m is not an integer number. We need the floor of this division. And for that, we have a special division, which is integer division. That's how many times m fits into k fully, okay? And j can be equal to that, except that now we have to be careful not to make the very standard +1 mistake. So if k is really small and j is equal to 1, a very small k divided by m is going to give 0, but j is 1, so we'll probably have to add 1 over here. And that's indeed true. So if the column fits once, that means we're in the second one, and that means j equals 2 and so forth. Now I, that's basically how many rows fit in the column where we actually are, and that means that we can take the remainder of k divided by m, and for the remainder we have this special operation in Python. Very nice, and that's about it. So let's return this, and we're going to return this as I comma j, which actually creates a tuple. I could write it this way, but in Python for tuples the normal brackets are not necessary. We can just leave it like this, and that sort of looks like we are outputting two outputs. Okay, let's test this. Let me write a little test program. So let's fix m to, I don't know, 8. And let's cycle through I and j. So say I in a range, I should go up to m, right? And for j in a range, how many columns? I don't know, 10. Let's just make okay, let's first calculate k. K is going to be k of I, j, m. And let's calculate the inverse I1, J1 as Ik of Km, like this. And let me create a fancy output to say that we went from one point to one index to the K to the other index. Okay? So here we want to put I, J, K, I1, and J1, like that. And we just need to find the formats for all these numbers. These are integers, so this format %d is a suitable one. So this is going to be for I and J, and the I and J that we recover, and K itself over here. Okay, so we are ready to run, and here we have some first errors, which is okay. Let's try to see what's going on here. Not enough arguments for format string. Okay, that's actually a pretty nasty situation or nasty mistake here. In print statements, the second argument, or the argument that follows this formatting sign, needs to be a tuple, so we have to enclose all of these variables into curly brackets explicitly here, because otherwise there's no way of knowing that this is a tuple. So what do we have now? Int object is not callable. In line 17, as you can see, there is an error. Okay, so when we're calling this k as a function, and we are saying that k is not going to be a number, and the next time on the next iteration of the loop when we call it, then it appears like we're calling an int as if it was a function. Okay, so let's say k0 here, and then of course we need to change it everywhere else. k0, just give it a different name. Okay, and here we are. We start with some index, we output, oh, I can see a problem here. And then we go back to the index. Well, the conversion back seems to be working fine, but this -8 cannot be a k index. What's going on? See how range goes from 0 to up to m? And the same thing here. And we thought that the indexing starts with 1. Isn't that right? 1 to n and 1 to m, not with 0. So I guess we could say here that we can say start from 1 and here start from 1. And now the index 1, 1 is going to be converted to k1 and back to 1, 1 as we would expect. And it seems that everything is working. The conversion and the inverse working fine. Well, this is of course okay, but shouldn't we also index from 0? I mean, in the Pythonian way, this is how it's done. The answer is yes, we should index from 0. Let's try that. So let me draw this matrix again. And now let's start let's start from 0, 1, 2, and up to n. And I starts with 0, 1, 2, and up to m. And now k will also start with 0. And end at m minus 1, right? The last element is going to be m minus 1 if there's all together m rows. And so m goes here, m plus 1, and so forth. 2m goes here, and finally we have nm minus 1 as the maximum k. Now let's try to convert the same sort of spot here. And of course, I'm just trying to make a big blob. And of course, the logic is going to be just the same. We have to calculate how many m's fit into k. You know, not to completely break the code, let's make another input argument here. And let's call it base 0 equals true. Base 0 meaning that we want to use base 0 indexing, starting from 0. And this should be default, of course, in Python. So if base 0, then we have to write some code. Else base 0 is actually the is pretty much an alternative to base 1. So else will be our base 1 code. And let's start with this one. So how do we calculate k? Well, we have m and another m, so it's going to be m times something as before. So it's going to be m times. Now, how many j's do fit? How many times this column fits into k? It starts with 0, right? So say 1, 2. If j is equal to 2, that exactly means that 2 columns fit into k. So in fact, we just have to multiply with j now, not j minus 1. And then the number of rows is also going to be I. It starts from 0 now, but that's fine because think about the first element. That's going to be 0 columns and 0 rows, and this is 0. This is what we want. Okay, so the formula became actually easier. And it turns out that the inverse is also just like that. We divide k by m in the integer way. We find that, so for example, 2 columns fit into 2 m's fit into k, and that exactly means that we're in the second column in j. So j will be k divided by m, that's all. And then I, sort of similarly to the logic here, is not going to change. It's going to have k divide the remainder of the k over m division. Okay, I think we are done, and let's move the ones away and do it in the Pythonian way. So there is another problem. Cannot unpack non-iterable non-type object. The error appears over here. So let's stare at the code for a second. Why is ik not returning? Can you see why? Yes. So we do have a return in this block of code, but we don't have a return in this block of code. And that's simply because we didn't put it there. And this return only belongs to the else statement. So it's enough to move it out to the same level as if to make it belong to the program, to this function sort of after if. And I think that's going to be enough. Yeah, that's going to be enough. And this is how our conversion now works, starting from 0 and 0 over here. And you can see that, well, let's make it slightly smaller. Maybe 4. M equals 4. And then I can draw this example here so that we can actually see that it's doing the right thing. Let it be 4 by 4. And the case will be, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And m minus 1 is expected. So what do we have here? 0, 0 is 0, 0, 1. 0, 1 is this element, should be 4. And it is 4. 0, 2 is 8. 0, 3 is 12. So we are moving over here. 0, 5 is 20. Oh, there is a slight problem here, right? That I've assumed that there are many more columns. And so on my graph, I would have more columns. And you can see here why we don't really need to know how many columns there are. It's going to be 16, and then 20, and so forth. But you can see that the inversion works really nice. So whatever we put into k, we get back out of inverse k. Okay, that's good for the first exercise. And let's move to the second one. In the second exercise, we are asked to write a function which converts a decimal number into a given base, into a number with given base. I guess that's what was meant. Into a number with given base. Results will be returned as a string. All right, so let's create a function. I don't know, base n. And it should get an x and b, x as the value to be converted and b as the base. Docstring. Converts x from decimal to base b. Okay. Returns string. All right, so what should we do here first? Let's think. So if b is less than 10 or equal to 10, then we can use numbers to represent this this converted, the output, the result, right? But what happens if b is greater than 10? Should we allow this function to work also with bases above 10? Maybe we should give b some default value, and I'd like to give it 2. Just as a simple base. By the way, can base be less than 2? So if base is 1, then all the digits in the number must be 0. That's not helpful at all. So if b cannot be 0, then we have to assert a condition that b is greater than 0 but less than some upper bound. Now, what's that upper bound? Let's think about that. So for the case where the base is greater than 10, we need to come up with some new digits, new symbols to write the digits. So maybe we can combine all of these possible digits into an array, and then b should be less or equal than the length of that array, right? Because say the array from 0 to 9 gives us length 10, and that's exactly right. So the length of the array should be the upper bound inclusive of the bases. Now, if that's not true, then we can say cannot convert to given base. It should be between 2 and some number, which I don't know yet, but let's give it a length of the digits. Now this assert statement, we didn't see that before, but it basically checks the some condition, so it has a logical expression here, and if the condition is not satisfied, then it throws an error with a description here. And this is a very nice way to check what the inputs into the functions are and whether they are the way that you expect them to be. Okay, now what about the digits? I want this to be a list so that length exists. So a list of, say, I for I in range 10. That's going to be a list of all of the digits between 0 and 9. And to this, we can attach a list of, well, what should we use for digits? Characters, I guess. So characters for I in some other range. Now, what is this function chr? Let me just create another cell here. Say help chr and run. Returns a Unicode string of one character with original I. Okay. Unicode string. Well, Unicode is the same as ASCII if the code is not too large, so they overlap in the beginning. So let's look at the ASCII table. I don't know, any website would be okay. So I'm interested in the lowercase letters between A and Z and decimal codes of them. So 97 till 122. 97 till 122. And so this range will give me that. Okay, so just to be sure of what's going on, let's just print digits. And of course nothing happens because this is just a function. Let's try to convert into base n something like, I don't know, 100. Okay, and there are all our digits. And this is what we wanted, right? It's 0, 1, 2, 3, 4. I see a problem here. So these are numbers, and these are strings of one character. It should be better. It should be that all of them are characters. So let's add string here. So we convert a number from a range into a string. Yeah, otherwise we could just use the range itself, but we need to convert it. Okay, so all of these are now one character strings, and if we wanted, we could actually, use some other symbols for the digits in our number system, and allow for even larger bases. Okay, so what do we do next? Well, similar to the previous task, actually, the key idea here is that to find out about the digit, we need the remainder of the x divided by the base, right? So think of a number that is divisible by 10, and that means that the digit, the lowest digit is 0, and if it's not divisible by 10, then it's the remainder of the division by 10, which is the lowest digit. And so to find the lowest digit, we can just use this. Well, this divisible by 10, that's going to give us basically an index, right? So if the basis is large and x is also large, then we can get an answer here above 10. That's okay. We just need to take a digit from this list here. So we're essentially treating this as index. So we can use this as an index into the array of digits, and this is going to be our next digit, or our current lowest digit. And I'm saying current because then we can say that x should be updated to the integer division of x by b. And so that basically means that we are losing the next digit in the number, and we are storing the number. This can be written in a shorter way, like so, right? Divide by b and leave result in x. And of course, I'm thinking about some sort of a some sort of a loop to do that many times. So this is our next digit. When should this loop stop? Well, it's when x doesn't have any more digits, right? So that's essentially x equals to 0. So while x is greater than 0, that means that there are still a number of bases in there. And the last digit, the highest digit, is C. If x is less than b, then this will give us the last digit. And this will evaluate to 0, and the loop will be completed. All right, so the answer, and let me say, call it an output. Let's initialize an empty list, and then just append to this list the next digit, and continue. So let's return this list for now. Okay, there is an error. Of course, I forgot a semicolon. Okay, so 100 converted to base 2 is seems to be 0, 0. It's a little bit hard to understand, right? So let's start with 1. 1 is 1. That's clear. 2 is 0, 1. So the digits are, of course, appended from the lowest to the highest. So in the return, we should swap... I'm sorry. We should swap this list by slicing it with the step -1 from the first to the last. And this way, the list now has a 1, 0, and say 4 is 1, 0, 0. Yeah, 4 is in base 2 is 1, 0, 0. Okay, now I want it to be a string. And remember, we used this just recently. Join... using this character, just join all the strings in the list here. And that's going to give me a string of 1, 0, 0. Okay, is that all? Let's try 0. And 0 returns an empty string. And that seems to be a special case, right? So if x is 0, then this never is executed. And then we have an empty output. Well, let's just check for that. Out equals a list with just 1, 0 if length of out is 0, else out. So we are replacing this list if it is of length 0, otherwise we don't touch it. Otherwise we just make it equal to itself. How about there? Okay, so now 0 is converted to a 0 as it should. Let's try some different bases and different numbers. In base 3, 10 is 101. So this is 1, and this is 3, and this is 3 square. So 3 square is 9, plus 1 is 10. Yeah, that's how that looks right. 12 is 110. Is this right? So this is 3, and this is 9. Yeah, that seems to be okay. How about 27, which is a cube? And so it is 1000, right? Because this is 0 of 1, 0 of 3, 0 of 9s, and 1 of 27th. Yeah, that seems to be working. How about some large bases? Can we do 100 base? Oh, there's our assertion. Cannot convert to given base. It should be between 2 and 36. Okay, so the largest base is 36. 27 and 36's base is just R. Okay, what about 36 and 36's base? Of course, that's 10, right? And 35, that's a Z. And some very large number should contain some Z's and some numbers. Some letters, I'm sorry. So here's a large decimal number converted to the base 36. Maybe we should do a little illustration and just go for some numbers and convert them into different bases. So for, I don't know, n in, and let's just give it some list here. And let's loop over bases. Well, we can just take a range from 2 to 36 actually. And let's make a print statement. In base is... Now this percentage sign S, that's a standard output place for a string. And okay, let's not forget this tuple here. And in the base B is base N of NB. I think that's what I wanted to see. All right. Let's make an additional print statement here to separate the blocks. Okay, 1 in base 2 is 1, 1 in base 3 is 1. Well, 1 is in any base is just 1. Same thing with 0. 0 in any base is just 0. 4 in base 2 is 100, or 100, I should say. Yeah, that's right. What about 4 in base 3? Well, that's 1 of 1s and 1 of 3s. 4 in base 4 is 10. That's correct. And it should be the case like 35 in base 35 should be 10. Oh, by the way, we're missing base 36, and that's because this range, of course, goes to 36 exclusive. Let's include 36 now here as well. And as the numbers go up, you can see that in lower bases, they tend to take a lot more digits. And here's the Z number in base 36, just one digit here. And as we look at larger and larger number, you can see how many digits it takes in base 2 and, lower number of digits in higher bases. Well, that seems to work. I think we're done. See you next time.